Good day, guys. Welcome to another exciting episode of Farmers Tutorials. If this is your first time, kindly subscribe, like, share, and also after watching the video, if you have any question in mind, you can put it under the comment section. Yeah, so our topic for discussion today is the Lorenz Curve. And the Lorenz Curve was invented by a man named Lorenz Curve, hence the name Lorenz Curve. And he did it in the year 1905 in America. He wanted to know the income distribution, or how there is an inequality in the wealth of the people in America. So he did the Lorenz Curve. And the Lorenz Curve is a graphical method which shows the extent to which magnitude differs from uniformity, or the extent to which magnitude varies from uniformity. And let me paint this picture to you so that you get a clear understanding of what the Lorenz Curve means. So let's say we have an industry, and in economics, when we talk about industry, an industry simply refers to the concentration of firms in a particular or in a geographical area. So let's say this industry consists of 10 firms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And with all these 10 firms, in a year they were able to contribute to an amount of sales, let's say 1,000 Ghana cedis. Yeah. In a year they were able to contribute 1,000 Ghana cedis as an annual sales. So we want to know how each of these firms contributed to this 1,000 Ghana cedis. So we will start by taking the first firm, right? So if you pick the first firm, and we notice that out of this 1,000 Ghana cedis, only this firm contributed to, let's say, 950 Ghana cedis out of this 1,000 Ghana cedis. That means that only this firm contributed almost 100% of this 1,000 Ghana cedis. I don't know if I'm making sense. That means that the remaining of the firms, they contributed very, very less to this 1,000 Ghana cedis. That means there is a huge inequality between the firms. I don't know whether you get the point. Supposing they all contributed the same amount to this 1,000 Ghana cedis, the amount that this one contributed will be the same as the amount that this one contributed, and for the rest of this industry. So before you can construct your Lorenz Curve, there is something that you have to take note of, and I will be explaining it as we go along. Yeah, so you have to know the cumulative of both magnitudes. So the number one, you find the cumulative of both magnitudes. And the second is you find the cumulative percentage of both magnitude. And the last one, you find, or you construct your line of equal distribution. So these are the three things that you have to know. So let's take them one after the other. So let's say you are being given an establishment. So let's say we have establishment. And we also have, we are being given their frequencies. And their output in a year, or what they were able to produce in a year. So this is their establishment, and this is their output. Right. Yeah, so let's see something here. So let's say the establishment, we have their frequency to be 2, 4, 8, 9, 10. Right. And the output, we have 20, 40. let's see, 60, 70, 120. So this is an establishment against their output. So first of all, you find the cumulative of both magnitude. So the magnitude here are establishment and output. So first of all, you find the cumulative of the frequencies of the establishment. So the cumulative, right? So this is how it is done. For the first figure, you will just write it there. And with the next one, you will add the 2 to the next one, which is 4, which will give you 6. Then you add your 8 to your 6, which you will get 14, right? Then you add 14 to 9, which will give you 23. Then you add 23 to 10. Then you add 33. So this is the cumulative. Then you do the same for the output. So the output here also 20. Here is cumulative, right? 20 plus 40, which will give you 60. 60 plus 60, 120. 120 plus 70, 190. 190 plus 120. 190 plus 120. 310. Right. So when you are done like this, the last figure that you get here is the total number of frequency. And the last number that you get here is also the total number of output. So now we are done with the cumulative of both magnitude. We are here to find the cumulative percentage of both magnitude. So now we are coming to find the cumulative percentage. So this is how it is done. You will pick the first cumulative, which is 2, and you divide by the total of your frequency. So the total of frequency here, we had 33. If you add this all up, you get 33. Then you multiply it by 100. So you 2 over 33, then you multiply it by 100. Then when you come here also, 20 over 310, then you multiply it by 100. So the answers that you will get will be in percentage. So this is just a rough sketch, but I wanted you to know that in constructing of your Lorenz scale, you have to know your cumulative of both magnitude, which I just did. Then the cumulative percentage of both magnitude. That is each magnitude or each frequency on the establishment over the total of the frequencies times 100, right? Then the line of equal distribution is only done when we are doing the construction. So when we reach there, I will explain it to you. But what the line of equal distribution simply means that it is a line which shows that supposing the establishment, they contributed the same amount of output, then the curve is supposed to lie on the line of equal distribution, right? So I will explain that in the construction of the Lorenz scale. So I have an example that I want us to look at. Yeah, so looking at the example on the board, this is how it's going to look at if you construct it tabularly. So, like I said, you first have to find the cumulative, then the cumulative percentage. The cumulative percentage is what we are going to plot on the graph. So first of all, let's find the cumulative of the citizens. So, like I said, you will maintain the first one, the first figure, which is 9,133. Then you add it to the next one. You add it to the next one, which will give you 10,636. Then you add the 10,636 to the 5,406, which will give you 11,182. So you add 11,182 to the preceding one, which is 95. Then it will give you 11,277. So you continue like that. Here will give you 11,328. The next one will give you 11,350. And the last one will give you 11,355. So you are supposed to arrive at the total of the frequency. So after we are done with this one, the next thing that we have to construct is the cumulative percentage frequency. pardon us for the space, the board is not big enough, but we will try and maintain the space being given. So for the cumulative percentage frequency, you first take the first one, this first digit, then you divide by this 11355, then you multiply by 100. So we want to know the percentage that this figure 91333 has in the total figure, that is 11,355. So you first 9133, then you divide by 1135, then you multiply by 100, which will give you 804. Yeah, so the first one is 80.4, so you will maintain 80. So the next one also, you divide 10,636 by 11,355, then you multiply it by 100, which will give us 93.6. So we will maintain the 93. Since we have decided to not include the decimals in it, we have to maintain it throughout our calculations, else there will be some variations. Yeah, so we will do the same for the rest of the figures. So the next one will give you 98, followed by 99, then you add another 99, another 99, then the last one is 100. And the last one is always supposed to be 100 because we are talking about percentage up here. So you come to the next one. So like I said, in calculating for the cumulative, the first figure you have to maintain it. So here will be 2,511. So the next one you add 998 to the 2,511, then you get 3,509. Right. So 3,509, then you add 1,002 to it. You are getting 4,511. 4,511, you add 9,701 to it, you get 5,482. So the next one also, you add 1,024, you are getting 6,506. The next one will give you 7,491. The last one is 2. Like the last one is supposed to always give you this amount. I hope it's very clear. Yeah, so now that we are done with this one, we are moving to the cumulative percentage. And like I said before, we will be constructing the Lorenz curve with the cumulative percentage of the frequency and the cumulative percentage of the total or the amount, right? So the cumulative percentage of the amount, like I explained here, you will divide this first one by the total of the amount saved, then you multiply by 100. So let's do it together. So 2511 divided by 8504, then you multiply by 100, you are getting 29.52. So we maintain the 29. Then you do same for the rest. The next one is 41, followed by 53, followed by 64, followed by 76, 89. Then like I said, the last one is supposed to give you 100. So the most important factors here that we have to take note of is the cumulative percentage of the citizens and the cumulative percentage of the amount. These two is what we are going to construct on the Lorenz curve. And here is in percentages, here too is in percentages. So now let's look at how we are going to construct our Lorenz curve. So the first thing you have to draw when you are constructing your Lorenz curve is the line of equal distribution. And the line of equal distribution is a 45 degrees line from the x and the y axis, in between the x and the y axis here. So it's like this. So it's a straight line passing in between the x and y axis. So when you are done, you indicate line of equal distribution. Yeah. And what this line means is that supposing the cumulative percentage savings by the savers was equal, in other words, they contributed the same amount for the savings, the curve that we are about to draw is supposed to lie on this line because it's a line of equal distribution. And the farther away the curve is from this line of equal distribution, the wider the difference between the cumulative savings by the savers. I hope that is clear. Yeah, so let's plot our Lorenz curve. So the first 80 of the savers contributed to 29% of these savings. So you start on 80, then you look for 29. So here is 20, here is 40, in between you have 30. So 29 will be somewhere here, right? Yeah, so we have our 30 here. And the next one is 93 against 41. Here is 90, and the other one is 100. Yeah, here is 80 then 100. So in between 80 and 100, we have our 90. So 93 will be somewhere here. So 93 against 41, and here is 40. So just above the 41. So this is how it will be. Then we have 98 against 53. So 98 will be closer to 100 against 53. Here is 40. So 50 will be somewhere here. 53 will be just above 40. So it will be somewhere here. Yes. Then the next one is 99 against 64. So 99 will be closer to 100 against 64. Here is 60. In between is 70. So 64 will be closer here. 64 will be somewhere here, yes. So it will be somewhere here. Followed by another 99 and 76. So 99 again. 76 is somewhere closer to the 80. So 76 will be here. Then you have another 99 and 89. So 89 will be closer to this place. Because in between 80 and 100, we have 90. So 89 will be somewhere here. So we stand on 99 again, then we look for 89, which will be here. Then the last one is 100 and 100, which will be somewhere here. So after you are done, you just draw a freehand sketch line from the origin of the cumulative savings and the cumulative percentage of savers to pass through all the points. So this is how it will be. Then you just draw a stripes or whatever you call it within the space given. So you can see. So as I was saying, the farther away this line from this, the farther away this curve from this line of equal distribution, the wider the difference between the cumulative percentage of savings by the savers. So this is how it clearly means, and you can easily read it from here that there is an inequality between the distribution or between the savings of the people here. So in conclusion, you can see that 98% contributed to only 53% of the savings. Can you imagine? 98% contributed to only 53% of their savings. That means a very small number contributed to more percentage of the savings. So this brings us to the end of our Lorenz curve. If you have any question, you can put it under the comment section. Thank you very much.